an absolute value function would look like. And then I'm going to show you one way today on how to graph them. I'm going to later on show you another way on how to graph them, but today I'm going to show you the not necessarily simple. Well, I mean, I guess it is the simplest way, yeah. This is just the first way I'm going to show you how to graph them. So, an absolute value function is something that would look like, say, y is equal to the absolute value of x minus 2, and then close absolute value. So you guys remember these straight up and down bars mean absolute value, right? And so the absolute value is something that can't be negative, but that's not the same thing as saying it's always positive, because it could be equal to 0, and 0 isn't positive. 0 just isn't negative. You guys remember the difference between those two things? Because 0 has no value, 0 isn't positive or negative, but
0 is unknown.
It's not that it's unknown. We know what 0 is. 0, 0. It's just that it's not negative. All right, so here's how we're going to graph this. So step number 1. You're going to make yourself a table of 7 values. Make a table of 7 values. And these 7 values are going to go from -3 to +3. So the table of 7 values, bless you. We're going to have x on one side, we're going to have y on the other side, and then x, bless you, x is going to go from -3 up to +3. And once you do that, you're going to have a total of 7 values, which is why it's called a table of 7 values. So I'm going to go, x is from -3, so -3, -2, -1, 0, 1, 2, and 3. And that's a table of 7 values. So that's step number 1 for how I would graph this. Step number 2 is I'm going to sub in those values for x and find y. So what that means is I'm going to take, starting with -3, I'm going to take -3, I'm going to put it in where x goes, and then I'm going to use that to find out what y would be. So
Why -3?
because the tables that we're going to be using on our value, on our assignment today, are going to go for every one of them from -3 to +3, because that's just what you're being told to start with. There's another method I'll show you in the future that has the tables be different every time, and I'll show you that later. But for now, every table that you're going to go do today is from -3 to 3. Okay? In the future, there's another method I'll show you that I'll teach you how to know where to start the table and where to end the table. But for now, you're going from -3 to 3. Okay? So we're going to take this value, which is what the x is. We're going to put it in for x. And so we're going to do absolute value, -3 minus 2, absolute value. So now we got to evaluate this. So what is -3 minus 2? Anybody? -5. So this is absolute value of -5. What's the absolute value of -5? Just plain 5, right? Now I'm going to do the same thing for each of these other values of x. Now I don't have to actually write out, I don't have to show all of these steps. I'm doing this just so that you can see what I'm doing here to get these values. I could even probably do it in my head if I was careful enough. What's -2 minus 2? What's the absolute value of -4? So I could just write this down as 4. Do you guys see that? I just wanted you to be able to see where I got this 5 from. Alright, so if I put -1 in here for x, what's -1 minus 2? -3. And what's the absolute value of -3? What's 0 minus 2? And what's the absolute value of negative 2? What's 1 minus 2? What's the absolute value of negative 1? What's 2 minus 2? What's the absolute value of 0? What's 3 minus 2? And what's the absolute value of 1? Not negative 1, just 1. And so you would expect this value here to end up being negative 1, right? Because you had this nice pattern going where you went 5, 4, 3, 2, 1, 0. You would expect this to be negative 1, but it's not. Because if you put 3 in for x, 3 minus 2 is 1, and the absolute value of 1 is still 1. Absolute value doesn't turn positive things negative. It keeps positive things positive. Right. It makes negative things positive, but it doesn't make positive things negative. It makes everything positive. Like everything turns positive in this club cranium. Okay? Kind of, sort of? All right. So now, step number 3 would be that we would graph these points. So graph these points. And when you graph these, you're going to end up with this like kind of check mark looking thing, and I'll show you exactly what I mean by that. So you're going to have to bear with me here because I don't have an actual piece of graph paper in front of me. So I'm going to make a piece of graph, make an XY axis on my thingy thing, on my notebook paper here. So here's my x-axis, here's my y-axis. So I'm going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So I've got my my graph in there. My first spot is going to be negative 3, positive 5. So 1, 2, 3. 1, 2, 3, 4, 5. And then negative 2, 4. And then negative 1, 3. And then 0, 2. And then 1, 1. And 2, 0. And then 3, 1. And when I connect them, it makes this kind of check mark thing. So what's happening here is this is what an absolute value function looks like. An absolute value function, instead of looking like just a straight line that goes on for forever in one direction, or in both directions, an absolute value function will always have this kind of bounce back point, this place where it reaches a smallest value and then it bounces back from that smallest value. And that place where it has its smallest value, this is called its vertex. I know you guys have heard that math term before, vertex, right? It's a point, absolutely. Now I'm going to label the vertex, and I'm going to say exactly what the point of the vertex is. So at what point is the vertex? Not 0, 2, I got to label x, y. So it's 2, 0. It's not 0, 2, because it's x, y points. So it's 2, 0. So the vertex is at 2, 0. And that's the lowest point that this will go. It's going to go now forever up. So forever now it's going to go up in both directions. It's never going to go any lower than 2, 0. Kind of, sort of? Yes, no, maybe so? Cool. So that's graphing absolute value functions. Now, there's a little more to it than that, but that's how I'm going to introduce it to you guys today. um, as far as picking where your table of 7 values goes. For today, I'm going to have you guys do your table of 7 values on every part of your assignment from -3 to 3, okay? So there's 10 problems where you're going to be graphing these. And for every one of the 10 problems, I want you to graph them from -3 to 3, okay? You'll have to show your table of 7 values. You'll have to graph them and then say where the vertex is. And then there's a few, very few review problems on today's assignment. So let's take a look at that, and then you guys can get on with it. So where did I actually put your assignment? Aha! Here it is. Okay. All right. So on this piece of paper is where I'd like you guys to make your table of 7 values and like say what the vertex and stuff is. I didn't include a graph on this piece of paper though. So for the graph graph paper, look how ordered it is. Isn't it awesome? Nice and orderly. Wonderful. All the boxes. You're only going to need one piece because there's like a bajillion graphs on here. 24. Okay, 24, a bajillion. Same thing. Okay. So let's go through at least one of these here. And then, yeah, I mean, you guys can work together if you want to. That's totally fine. All right. Before you go any further, too, make sure you put your name on this. I've been getting a lot of no-name assignments lately. So before you get too far into it, make sure you put your name on it. Please and thank you. Sorry for what? Okay, so on number 1, you have to put, you put the -3 into the absolute value, and then you subtract the -4 after you do the absolute value. So -3 in for x, so what's the absolute value of -3? And then what's 3 minus 4? So this is -1. -2 into absolute value, so what's the absolute value of -2? And what's 2 minus 4? -2. What's the absolute value of -1? And what's 1 minus 4? Absolute value of 0 is, and what's 0 minus 4? What's the absolute value of 1? No, it's positive 1. So absolute values don't make any, they don't change signs. Or they do change signs, but they make everything positive. So if it's already positive, it stays positive. And if it was negative, it becomes positive. So the absolute value of 1 is 1. And then what's 1 minus 4? negative 3.
But we don't make the y into positive, like after y.
No, it doesn't, like, it only changes what was inside here. So if I put 2 in for x, the absolute value, like the magic of the absolute value only affects what was inside these up and down braces. It doesn't affect anything outside of it. Okay? So if I put 2 in for x, what's the absolute value of 2? 2. Think of it like distance, okay? So like it's how far away this number is from 0. So if I put, how far away from 0 is 2? 2, right? It's 2 units away from 0. So, and what's 2 minus 4 then? Negative 2. What's the absolute value of 3? And what's 3 minus 4? Negative 1. Cool. So there's the table of 7 values. Now I need to graph that. So I'm going to grab my super trippy piece of graph paper here that some of you guys are having trouble looking at. I'm going to label this one number 1 so that I know which one goes to which one. And I'm going to graph it. So I'm going to go, here's 0, 0. I'm just going to make a dot so that I know where 0, 0 is. I'm going to go to negative 3, negative 1. So 1, 2, 3, negative 1. Negative 2, negative 2. 1, 2, 1, 2. Negative 1, negative 3. 0, negative 4. 1, negative 3. 2, negative 2. 3, negative 1. I'm going to connect them with a vaguely little line thing going like that. I'm also going to circle the vertex. I'm going to say my vertex is at, what's the point of the vertex?
I put the vertex on the negative
0, negative 4, right? So 0, negative 4. And if you put the vertex over here, if you put vertex 0, negative 4, and you didn't put it on here, that's fine. Totally fine. Kinda, sorta? Sorta, kinda? You're looking super confused, Juju.
No, I'm just trying to see the board.
Oh, okay. You move back there. I know.
She has drop paper phobia. I want to know what that's called.
Cardophobia, probably.
What?
Graph paper, being afraid of graph paper is probably cardophobia.
Cartophobia?
Cartophobia, yeah.
Why is it probably that?
Having things arranged like this is called cartography. Mapping stuff out.